SwayamPrabha. Digital India. Educated India.
Let us start this lecture with a thought process which is very important for human life, that is satisfaction, happiness and peace are three pristine pedestal of human life. In the last lecture, we basically discussed about the impingement atomizer, and we only looked at how to analyze a simple doublet impinging atomizer, and we have derived some expression for angle and considering an ideal cases of elastic collisions between the two impinging liquid jets. Of course, before that we looked at an example how to calculate of various parameter for an atomizer. So, today we will be discussing about the injector distributor. A question might be coming to your mind, why injector distributor is required and what are its function? If you look at the application wise, for a smaller rocket engine with a very low thrust level, one can use a single injection element or a single injector. However, for medium and high thrust level or for getting higher specific impulse, then one has to use the series of injectors in case of liquid propellant rocket engine. And when you use several numbers of injectors, question arises how you will house in the injector head. We have already looked at that. Let us again visit that this is your injector head, or we call it as a injector distributor, and this is known as injector head, this portion in a, and this is your let us say fuel pipe, fuel inlet, this is let us say fuel inlet, and this is your oxidizer inlet. Keep in mind that these are all injectors, and this distribution how it is, these are injector distributions, and this all if I consider this is a injector, these are small orifices and is being arranged, and this arrangement is a very important aspect, and the objective of these arrangements are having several fold. The objective of these injector element arrangements are having several function to do, and particularly that it is used to have a uniform heat release and higher combustion efficiency. If heat release is not uniform, it may lead to several problems, and beside this the combustion wall in case of a liquid propellant rocket engines are exposed to the high heat release, and if the oxidizer stream will be near the periphery of the combustion chamber wall, then it may be eroded. As a result, the failure may occur. Therefore, one has to take care of that thing while designing the rocket engine. And beside this, there will be proper heat exchange between the propellant and the burnt gas. That means, whatever the propellant is being injected and atomized or vaporized, that should be really well receiving the heat, such that you from the burnt gas, such that you can have easier vaporization or the fast vaporization. Beside this, the fuel and oxidizer need not to be well mixed, or maybe the pre-mix combustion will be taking place, then the combustion instability has to may occur. In order to avoid that combustion instability, the injection pattern or the distribution of the injection element and the injector head plays a very critical role. So, therefore, it is important to look at the design. Various kinds of distributors have been used by the various designer, and however, we will be looking at only 4 of them just to show you that its importance. And keep in mind that 2 things are being used generally. One is that at the periphery of the injector head or near the wall region of the combustion chamber, the fuel injectors are being placed such that the fuel will be pyrolyzing when the heat will be coming, and then it is not oxidizing nature to erode the combustion wall. And also the combustion, intense combustion will be taking place inside the combustion chamber away from the wall. So, these 2 things has to be looked at, and also the homogeneous mixture must be avoided, and also the combustion should not take place near the injector head. And if the combustion is taking place near the injection wall and it happens to be in the fuel rich condition, maybe soot will be formed, and then the soot may block these injectors. As a result, there might be non-uniform heat release, and that may lead to the combustion instability as well, and some other problems will be coming into picture. So, let us look at only 4 types of injector distributor, and one is that concentric injectors. So, if you look at this filled circles which is corresponding to the orifice of an injector, single orifice, and that is fuel, and the non-filled or the circle is corresponding to the oxidizer orifice. If you look at, as I told earlier, that this is the last which is near the wall, and this is your wall. So, this is the fuel. So, therefore, it is properly placed and it will not really erode the wall, metal wall. And this is oxidized, this is in concentrated, that means one circle is here, one circle of the this is one circle, and then there is another circle, and there is another circle. So, if you look at this is known as concentrating. So, this is another. So, this is the one first circle, right. This is your second first circle of the oxidizer, and this is fuel, and then this is your basically fuel, second fuel and second oxidizer. So, it is a concentrating. Of course, the center there will be only one oxidizer injectors. So, concentrating is easier to manufacture and also easier to maintain it, and it is giving you of course, little bit late mixing. However, it is also the combustion will be good and the wall being protected, but it takes more residence time, and therefore, they need a little bit longer length combustion chamber for complete combustions. And whereas the honeycomb, which is being used very much, and it is having better mixing, and whereas in case of concentratic this will be having less mixing. If you consider this one, let us say this is your shape as a honeycomb shape, and this is your honeycomb shape, you are getting honeycomb shape atomizer, and similarly here if you look at another one, and it is being flanked with the fuel, and all the times the fuel, this is your fuel orifice and this is your oxidizer orifice. And keep in mind that this is little difficult and complex to arrange, but this will be giving you far superior mixing as compared to the concentrating, and the combustion will be more confined in the central region of the combustion chamber. So, that is the good part, so that the wall will not be affected. Beside this, the wall is having also the fuel stream, these are the fuel streams. So, that the wall is protected. There is another one which is being used is known as alternative. That means, if I go from this is your the oxidizer and this is your oxidizer, this is your fuel and this is your oxidizer. So, this goes on alternative way, this is alternative. So, similarly, here also it is alternative ways, and this is of course, you will get a better mixings as compared to the concentrating, but the number of the injectors per unit area is much lower as compared to the honeycomb and also the concentrating. So, therefore, whenever you are having a high heat release, generally people go for honeycomb or maybe concentrating, because honeycomb is the best one. However, alternative will be having lower, but it is having it gives better combustion also, because of fact that the mixing is better and then uniformity is also maintained. There is another one which is used very much, this is known as coaxial. If you look at this is your fuel center one and oxidizer is the around it, and this is being used particularly for the cryogenic engines. And this is being used which I have not shown, but in this case the wall has to be protected properly, and because the oxidizer is coming around that the wall and this is the wall. So, for that some people use the fuel streams over here and so that injector, so that the fuel will be around the wall of the combustion chamber. So, and this is of course, various varieties one can think of, one can really use is in a various format permutation combinations. So, you can now have a feel that it is a very important, and the design will be depending on the imagination of the person, but the basic purpose must be met by designing the injector distributor. So, let us now look at the what are the processes involved during the combustion of the liquid propellant. And if we imagine the liquid rocket engines, you can see that several processes are occurring simultaneously. When the fuel and oxidizer are injected, it will be injected at a very high velocity. Then the spray will be formed and of having several droplets of different sizes, and these droplets will be moving at certain high velocity. It will be vaporizing and it will be interacting with each other, and they will be colliding and coalesce and fragmented into smaller droplets, and also it will be receiving heat from the combustion zone. There might be a flame around the droplets and maybe some group of droplets, and the three modes of heat transfer which will be taking place simultaneously, that is your conduction, convection and the radiation, and the heat also will be transferred from the wall to this and injector plates, and the flow will be quite turbulent. There might be recirculation zone, there might be also the pockets, and the turbulence level will be quite high, and beside this will be moving at a very high speed. And keep in mind the flow will be not only the two phase, rather sometimes three phase, because the soot will be formed, and once the soot is formed, it will be also radiating the heat. So, the process is so complex, it is very difficult to really model it and analyze it even numerically. So, therefore, we cannot really discuss that in the class using some analytical tools. Even the processes is quite complex to even comprehend. Therefore, we will be discussing about in a very simplistic manner, and that we are going to discuss, and that is, let us consider a combustion is taking place in this diagram, and you are having fuel injectors, and this is your injector's head, and oxidizer, fuel, and oxidizer and fuel. This is the spray what will be formed, and spray will be occurring near the injector head, and this spray will be basically interacting with each other. Maybe CL layer will be there, and there will be mixing, liquid phase mixing may occur, and droplet will be formed, and then primary atomization, then secondary atomization, and then also the droplet will be moving with a certain velocities, and it will be evaporating. So, and also the flame might be occurring in sometimes. So, there might be some smaller droplets, right. So, therefore, it is a quite complex, and when it is start vaporizing, of course, you should have some ignition energy if it is really the non-hypergolic propellant, and if it is hypergolic propellant, in the liquid phase combustion can be taking place as well. So, when it is occurring, the heat release also will be increasing the velocity of the fluid, so also vaporizations. After this, the combustion will be taking place. As a result, the rapid combustion will be taking place here, and the velocity will be increasing. When the velocity increases, there might be the fluid which will be going into along with the 3 phase, as I told some, but definitely 2 phase, one is liquid phase, other is gaseous phase. Then the fluid will be moving in this direction. Of course, this I have shown you some streamlines, and then it will be very high velocity at the throat, and then again expand in a nozzle, and sometimes the combustion will be taking place till the end of the throat even. And keep in mind, this we call it the stream tube combustion zone, and the combustion will be subsonic in nature, and subsonic flow will be. So, let us now divide this process into various zones. The first zone what we will be considering from here is basically injection or atomization zone. This zone, this is the zone what we are talking about, injection atomization zone, and in which the injection velocity will be order of something 7 to 60 meter per second, even sometimes more, and the spray and droplet size and its distribution, and also the vaporization will be dependent on the injector pattern, sizes, and also number of injectors, the type of propellants, and the type of injectors. So, this is quite complex in nature, and as a result the vaporization will be taking place, and there is a heterogeneous zone here. This zone is basically heterogeneous zone. At least the 2 phase flow, sometimes 3 phase, and then containing liquids, vapor along with combustion products, some of the diffusion will be taking place. And the next zone what we will be considering is known as rapid combustion zone. This is your rapid combustion zone, and where the intensive chemical reactions are taking place, and chemical reactions will be quite complex in nature, and also if you want to model it is beyond the ken of the present day work, because there is liquid phase and this also the gaseous phase, and local axial velocity will be increasing at least by 10 times or even sometimes more, depending on the temperature ratio what will be there, and this is due to the thermal expansion. And beside this, a fuel rich and oxidizer zone might be occurring in various pockets, and the radial velocity becomes smaller as this combustion takes place. The radial component, if you look at this radial component, this is your radial, because if I consider this is your x axis right, okay, and this is your radial direction. So, radial component is this is your V x and this is your V r. V r is becoming very small as compared to axial one, particularly in the steam tube combustion zone and also in the case of rapid combustion zone. The steam tube combustion zone, the chemical reaction might be minimized. However, it will be definitely continuing at a very lower rate, and the velocity by this time could have increased to 200 to 600 meter per second, and thus the very little mixing will be taking place, as I told that V r will be smaller as compared to the V x, and the residence time will be smaller, and which is order of 10 milliseconds, and leading to the almost chemical equilibrium, but in some cases it may not be occurring. So, therefore, the processes are quite complex in nature, and let us now look at what are the processes occur during the combustion of non-hypergolic liquid propellant. And most of the things I have discussed, but to make it more clear and also understand it better. So, let us look at it little bit again, such that it can seep into your mind. And when you talk about this non-hypergolic propellant, that means there is no liquid phase combustion. So, first it has to be converted into spray forming of the liquid droplets, and this may be a primary atomization. That means, the ligaments are separated from the bulk liquid, and then ligament may be leading to a droplet due to the surface tension forces. There might be atomization, and there will be also secondary atomization due to the flow of the gas, and also there may be it will be impinging into each other. Depending on that, there will be secondary atomizations, and once this undergoes secondary atomization, there will be also the vaporization, and the fuel and oxidizer will be mixed. So, that there will be gas phase mixing, and once this gas phase mixing occurs, if it is high at high temperature, so that there might be a pre-mix flame. So, that is a flame which may be there in between, and let us say consider another case situations where the heterogeneous mixing of liquid and gas phase will be occurring. So, that there might be a droplets. If you look at, there is a, this is your fuel droplets, and there is a gas oxidizer. So, and if that is the case, that means there might be a flame which will be occurring. So, that is droplet combustion. This is your flame, and there might be several droplets which may be together, but nearby, such that there might be a group combustion which will taking place, or the spray combustion, and these are known as the diffusion flame. This is diffusion flame. So, and that means, if you look at both the diffusion flame and premix flame can really occur in the combustion chamber. There might be a flamelets also, and there might be a also known as the partially premix flame zone. So, the process is quite complex, but keep in mind that in non-hypergolic basically there will not be any liquid phase reaction taking place. So, let us look at the processes that occurs during the combustion of hypergolic liquid propellant. So, we will be considering the similar way, that is hypergolic propellant can really undergoing the liquid phase mixing, and during this liquid phase mixing there will be chemical reactions which will be occurring, and these chemical reactions really can lead to the change in the giving the heat to the droplets, and vaporization reaction in gas phase may can occur, and the mixing of the gas vapor can occur. So, there will be also the chemical reactions in the liquid phase. And there is another way I can think of, another, that atomization of fuel and oxidizer can take place separately, and then there will be vaporization of fuel and oxidizer, and when this vaporization occurs, basically in the gas phase there will be mixing between the fuel and oxidizer and leading to the reaction in gas phase. Again it will come back to the even pre-mix flame, and sometimes this vaporization and this will be occurring, but that might be mixing of the both the oxidizer will be taking place, leading to the premix flame. And there might be another things which will be occurring simultaneously, that means fuel and oxidizer will be there, as I told, this is your flame, and there might be a group droplets which is having some flame. So, these will be occurring, these are the basically again surrounded by a diffusion flame, and this can become better, so that it will lead to the combustion product. So, if you consider that way, that this process of the hypergolic liquid propellant combustion is little bit more complex as compared to the non hypergolic propellant, and there is several things which will be occurring, and keep in mind that this is a qualitative view of the process of what really might be occurring, but the real processes are yet to be unraveled by the scientist. Maybe some of you will be looking at these processes and understand it, and maybe contribute to the better understanding of this complex process. With this I will stop over. Thank you very much listening to this video lecture. Thank you very much.